by two guests from the Container Services Organization at AWS. So I'll let y'all introduce yourselves, maybe starting with Ellis right below me.
Hey, I'm Ellis Tarn. I'm a senior software engineer at AWS. I work on scalability and auto scaling and have been pouring my heart and soul into Carpenter for about a year now.
And Alex over here.
Yeah, hey there. Really excited to be here. Thanks for having us. My name is Alex Kestner. I'm a senior product manager on the Amazon EKS team. I've been working really closely with Ellis over the last 6 months or so to bring Carpenter to fruition, and really excited to tell you all about it today.
Okay, so first of all, I want to start off by saying that Kubernetes is obviously a very exciting space that a lot of AWS customers are interested in, and this week we have an interesting and very exciting announcement about something that we've developed to make your Kubernetes experience on AWS even better. And so my understanding is it's called Carpenter. Tell me a little bit about what the release is and what Carpenter is.
Yeah, so I think that what Carpenter is a great place to start because folks here may not be familiar, but Carpenter is a new open source, flexible, and high performance Kubernetes cluster autoscaler. So think about when your cluster needs more compute resources to support the workloads that are running in it. Carpenter will automatically launch the best suited compute resources to your workloads. So automatically adding and removing the resources that are required. And the release today is one that we're really excited about because it's one that we think makes Carpenter ready for production. We've run a number of scale tests on Carpenter so that it can support even the largest scale workloads that you can run on Kubernetes. And we're also really excited to announce AWS support for Carpenter in EKS clusters.
Wow. Okay. So a lot of customers have been scaling their Kubernetes clusters, either by hand or using like the Kubernetes cluster autoscaler project. So now they have a new option now with Carpenter. And I want to ask, about use cases for Carpenter. If I have a Kubernetes cluster, I have my applications running in it. What are the use cases where I say Carpenter is really something I need to add to my Kubernetes cluster alongside my applications?
Yeah, it's a great question. I think there's a couple of use cases that we found that customers have had trouble with the cluster autoscaler. One of these being, think sort of soft multi-tenancy. So this is a use case where customers, and kind of a classic Kubernetes use case, customers from maybe different teams in the same organization are all sharing a cluster, using its resources together, and we heard from customers that it's been really challenging to get auto scaling configured in these clusters correctly and to achieve the kind of efficiencies that they've been hoping to achieve by having everyone share the same underlying compute resources. So that, I think, soft multi-tenancy is definitely one where we see customers benefiting quite a bit from Carpenter. The other one is somewhat related, although a little different. So think kind of job-oriented machine learning workloads. You need to train a machine learning model or run some kind of a simulation. So the challenge here is similarly to get the same kind of efficiency that you'd hope to gain by migrating to Kubernetes, but you need to spin up many, many compute resources very quickly. And these are often really expensive resources, right? They're GPU accelerated instances, and they need to be put to their full use for as long as they're around because they're really pricey. So Carpenter is designed to spin up the resources for these kinds of machine learning training jobs really quickly and then spin them back down just as quickly once those workloads are finished.
That sounds very good. That sounds like it's going to be efficient. It's going to be saving me money potentially. I'm not going to have as many resources running at all times. I do have to ask the flip side of that too, though. Is there any use case where I'd say like I don't really need Carpenter in my Kubernetes cluster?
Yeah, I think that the sort of use cases where I can see Carpenter not quite bringing as much value to customers as compared to other use cases would be one where the workloads in the cluster are relatively stable. They don't have to scale very quickly or dynamically. They're sort of just humming along and have kind of a well-known steady state. And for use cases like that, I don't know if Carpenter would really be kind of deliver the most value as it would for the other use cases that we just talked about.
Good to know. Good to know. So another thing, I know people in the Kubernetes community, they really like open source projects. They really like vendor neutrality. And so one question I ask is obviously AWS has created this open source project and released it. Is it something that's just AWS specific, or is it something I can use outside of AWS if I want to in my own on-premise installation or elsewhere?
Yeah, this was one of the early discussions we had about the project. Is how do we think about compatibility? How do we think about different clouds, or even how do we think about running Kubernetes on AWS without EKS, or running kops or other deployment strategies? And so, we think that this problem is general. It's not an AWS specific problem. It's not an EKS specific problem. And so we really wanted to tackle the widest scope that we could. And so we've painstakingly architected Carpenter to separate out the cloud provider logic from the vendor neutral logic. And so that's allowed us to be compatible with kops on AWS or with EKS. And in the future, it creates an extension point where other cloud providers could plug in and get Carpenter's bin packing and scheduling and all the fancy logic we've implemented, get that logic available to their cloud provider. And the cloud provider interface is very simple. It's things like create instance, delete instance, describe instance types. And so any cloud provider could, in a relatively straightforward way, implement that interface.
That's pretty cool. So my understanding is that we have a provider out of the box for AWS, but I can build my own provider for other locations as well if I want to.
Yeah, exactly. So we've actually been chatting with the Cluster API team to figure out if we can get a Cluster API provider, which would, by extension, then give us access to every Cluster API cloud, which is a pretty large number at this point. So, potentially there's some room to have non-Cluster API support, but that's kind of what we're looking at in the short term.
That's awesome to hear. So we can talk about this, but I really want to see a demo of this in action because it sounds like there's a lot of features, a lot of cool things we can check out. And let's see what we have in terms of being able to see Carpenter in action.
Yeah, let me see if I can get my screen shared. So can you just confirm you can see everything?
It's coming up now. There we go.
So I have a split pane here. The top is just showing the pods in my cluster. I'm running a watch every 2 seconds. So it'll just give you kind of a running look of the pods. And at the bottom is the nodes in my cluster. I don't actually have 0 nodes, but this is showing nodes that are managed by Carpenter. So I actually have a single node in my cluster right now, but that's just not shown in this UI. That's actually where Carpenter's running. So Carpenter is installed as a operator in your cluster. I'm gonna just start by showing you the a simple YAML file. And so in here, we have what's called a Carpenter provisioner. And the provisioner is a custom resource that Carpenter defines that contains all of the scaling logic. So this is a super simple provisioner. It's one of the most minimal ones you can have. We talked a little bit about providers earlier. So this is the instance profile for AWS specific. So every cloud provider will have potentially any fields that make sense for that provider. So on AWS, we needed an identity to run the node with. And so we have an AWS specific field here that says the nodes in my cluster will run using this instance profile. And I've created this instance profile, and that has permissions to connect to the cluster, et cetera. And then I have one other tiny piece of configuration here, which is the TTL seconds after empty control. And that feature allows us to scale down instances after they've been empty for 30 seconds. That's a little sneak peek into what Carpenter does after the nodes are no longer needed. I also have a simple deployment that I'm going to create. I've called it Inflate, and it has 0 replicas. Has a simple node selector to say, please run on Carpenter instances, because I have a managed node group in my cluster right now, but I don't want to run these pods there. So this will just make sure that all these pods are running on the nodes that Carpenter creates. And
so
then I also have,
what I see here is it looks like the deployment itself is all just generic Kubernetes. I don't have to do anything special there to make Carpenter work other than that custom resource at the beginning, if I understand correctly.
Absolutely, yeah. So Carpenter is built out of this core idea that customers have already told us what they need to run, and they've told us via pod template specs or deployments or however they're specifying their pods. And so we use the scheduling constraints in pods, such as the resource requirements here, node selectors, node affinity, pod topology. We support all these things when we're doing the math to figure out how big should these instances be, where should they run, and what pods should run next to each other. This is running just a super basic Kubernetes pause image. It's the MVP of demo images. It wakes up and doesn't do anything. So I'm just going to apply the simple version quickly to my cluster. And you should see, I'm just going to start tailing the Carpenter logs as well. So this is just Carpenter after you turn it on. It starts all the controllers, starts watching the Kubernetes API server, and it's watching for pod events. So what I'm going to do is I'm going to scale this deployment to 10 pods, and we'll see what happens. So you can see Carpenter immediately jumps into action. We've already figured out a set of instance types that would work for this node. And then we've already launched the instance and bound the pod. So when we talk about Carpenter, one of the primary goals of this project is to be extremely fast. And we can talk about some of our speed goals in the future. But you can see here is that the time difference between recognizing those pods and getting the instance launched is just a couple seconds. And I'm going to jump over to this UI here and show you this node's 21 seconds old. It's coming up in US West 2A. We chose a C5A 4x large, and that instance type is large enough to fit all 10 of these pods. So if we had spun up less pods, we would have picked potentially a smaller node. And it's the C family, which is compute optimized. This is because it's requiring CPU resources and doesn't require any memory. If we needed some memory, maybe we would have gotten an M or an R. But you can see the node's already online at 47 seconds. The containers are already creating. They're all running within 60 seconds. And that's Carpenter in action.
This is really fascinating. Now, I do have a question looking at this. What if I wanted to ensure that my deployment was like high availability, and I wanted to ensure that it would distribute across 2 different smaller nodes rather than putting it all onto one node? Is that also something that I can configure or control with Carpenter?
Yeah, this is one of the mental model shifts that we have from moving from a static capacity world where you've already defined the nodes to a provisioned, tightly scoped, just-in-time capacity world. So traditionally in Kubernetes, the kube scheduler would, by default, attempt to spread your pods across many nodes because those nodes already exist. So you might as well use them. And one of the benefits of that is that you can avoid any potential outages, or if one of those nodes goes down, you don't lose all of your capacity. In Carpenter, we don't want to do 1 pod per node because it's fairly inefficient from a node overhead perspective. Any daemon sets that you have in the cluster or the kubelet, et cetera, there's a lot of room that's filled up in the node that isn't pods. And so by picking larger nodes, we can have more efficient packings. But then you have this availability problem. And that brings us back to the scheduling rules. So I'm going to show you the second demo I have prepared here, which is called topology. And this is, again, a Kubernetes native concept. You're probably familiar with it. And this is the same deployment, except we're using a topology key of topology.kubernetes.io/zone. So that means I want my pods to be spread across availability zones, and that'll help solve this problem you were talking about. And then we're having a max skew of 1, which means that I want to make sure that the imbalance between these zones is at most 1. And Carpenter will do that math for us. Again, it's the same image, the same size. And the other thing I want to point you to is I want to show off another feature of Carpenter here at the same time, which is the ability to apply constraints or requirements to your node. So if you remember before, we have the Carpenter provisioner that has the provider and the TTL seconds. But I've now added some requirements. So I've limited us to 4 different C5 instance types. I've also decided to say run in US West A, B, and D, but not C. I want to run AMD and not ARM, but you could specify the alternative. And then similarly, I say I want to run Spot instead of on demand. And this is all Kubernetes affinity rules. You could actually put these at the pod level as well. But we're going to see Carpenter now solve the scheduling constraints of both these requirements and the top topology spread requirements. So I'm just going to apply this topology demo.
And while Ellis is applying that, I just highlight the sort of flexibility that we're talking about there. When we say that Carpenter is a flexible cluster auto scaling solution, this is the kind of flexibility that we're talking about, where you may not need to be aware or care about the kinds of instances or compute resources that are participating in your cluster, but unless your individual workloads request certain capabilities of those nodes. So I think that this is definitely a great way to sort of explore the kinds of flexibility that Carpenter enables.
Yeah, it feels like it's hitting that balance point perfectly between I can configure constraints if I want to, but if I don't want to worry about any of that, I can just say, Carpenter, find me some capacity on the AWS cloud, and it goes out and does that for me, which is amazing.
Yeah.
Yeah, it's all about layers of controls or layers of constraints as we think about it. So at the top level, it's the infinite, flexibility of EC2, and then within there is, we look at the subnets that you have provisioned for your cluster and make sure we only pick zones within those subnets. And then in addition to that, maybe your provisioner has said, well, actually, I only want to run in these zones, or you can apply all these layers. And then at the very bottom layer is these pod scheduling rules that are also respected. And so you can configure really flexible and powerful structures using those layers of constraints. I just want to point out real quick here this TTL feature in action. So we scaled down those pods when I applied the new demo, and Carpenter put a TTL on the node right here. And then after 15 seconds later, we killed the node, cordoned it, drained it, and deleted it. And so now it's gone. I'm not paying for it anymore. And that whole process took about 15 seconds after the node was empty. But I could configure that to a longer amount of time. The main trade-off here is if more pods are coming into the cluster, you might want to actually reuse the capacity. So I'm just going to go ahead and scale up here. Remember, this is our topology demo that has constraints. We're going to run on Spot. We're going to run on C instance types. And let's see what we get. I'm actually kind of curious, since the spot market changes all the time, you never quite know what instance type you want to get. And so we've been fairly flexible with our instance type, just in case like the C5X large is out of stock. Maybe we can get a 2X large or 4X large instead. So you can see here we did a pod spread. So we computed packings for 4 pods and 3 pods and 3 pods. So that's spreading the pods across the 3 availability zones we selected. And we launched each of these instances in turn. And you can see we chose US West 2D, 2B, 2A. And interesting, we got a C5X large, 2X large, and 4X large. That's so interesting. The constraints are, of course, different depending on the availability zone. So you'll have different amounts of available capacity with Spot at different points in time. And that's part of the power of Carpenter as well, as being able to specify the level of flexibility. So just in case EC2 is out of some type of capacity, you can have your constraints be flexible enough that it'll pick something else instead.
That's amazing. So one last thing maybe we can touch on before we run out of time here, but comparing Carpenter to a Kubernetes cluster autoscaler that maybe a lot of Kubernetes clusters or cluster users are familiar with, what are the advantages of Carpenter here? Just in a nutshell.
Yeah, I think it's a great question. Oh, sorry. It's a great question because I think it is very similar in some ways, but also very different in others. One of the key differences here is that the cluster autoscaler expects certain similarities between the compute in a cluster, whereas Carpenter will dynamically choose the best suited compute to the workloads in the cluster. I think the other really critical difference here is around the performance at scale. One of the things that we made sure to focus on really closely was that Carpenter would continue to perform as well as it does in more modest environments, even as you start to scale to the limits of Kubernetes itself. This sort of these kinds of performance characteristics are really critical for the kinds of use cases we see Carpenter being best fit to. And I think that's one of the other major differentiations that I would point to. Ellis alluded to this earlier. We have some really aggressive goals around performance for the next year, for 2022. Hoping to get to the first pod/node launch down to 15 seconds, and then to be able to launch another 1,000 pods in 30 seconds. I think that these kinds of goals give a sense of how serious we are about performance and where we hope to see Carpenter go in the future.
That's utterly amazing. So I want to pop up the URL now for everyone to be able to go check out Carpenter there at https carpenter.sh. Is there anything else you'd like to tell potential users of this before we run out of time here?
No, just thanks so much.
We have a working group every 2 weeks. So like the Kubernetes SIGs, we have an open source meeting where we talk about designs, we meet our customers, we meet other contributors and hang out and have a good time. So you can find us.
So come join the group and ask questions or offer suggestions.
Yeah, come hang out. It's on Thursdays at 9 a.m. Pacific.
Thank you very much for showing off Carpenter, and I hope you all check it out.
Thank you.
Thanks.